Hey everyone, good morning. I am Priyanshu Agrawal and welcome back to my YouTube channel. Now we are going to see today's Leetcode daily challenge, rearranging fruits. Okay, so on the very second day of this month, we got a hard question. But yeah, let's see what is this question and how we can solve it. So in this question, you have two fruit baskets containing n fruits each. You are given two zero index integer arrays, basket 1 and basket 2, representing the cost of fruit in each basket. You want to make both baskets equal. To do so, you can use the following operation as many times as you want. First, choose two indices I and j and swap the ith fruit of first basket with the jth fruit of second basket. And the cost of the swap is minimum of basket 1 I and basket 2 j. Okay, and two baskets are considered equal if sorting them according to the fruit cost makes them exactly the same basket. And you need to return the minimum cost to make both the baskets equal, and if it is impossible to make both the baskets equal, then simply return -1. Okay, so in this question you have been given two baskets, basket 1 and basket 2, with n fruits each, and you need to swap some fruits of basket 1 with basket 2 and vice versa to make both the baskets equal if you sort them according to the cost of the fruits. And what is the cost of the swap? The cost of the minimum of the cost of the fruits you are swapping. Okay, so let's see with this example. Here your basket is 4222 and basket 2 is 1412. Okay, so here is 14, here is 14. Okay, here there is no one, but there are two ones. So maybe you can swap this one with this two. Okay, so what will be your cost? Minimum of 1 comma 2, right? So let's say your cost is 1. Now your 1 is here and your 2 is here. Okay, now here are two 2's, here also two 2's, here is 1 1 and 1 4. Okay, so let's see if you will sort this basket according to the cost. So what it will become? 1 2 2 4, and it will also become 1 2 2 4. So you can see both the baskets are same and the cost of swap is 1, right? Okay, so let's see another example as well. So here this is basket 1 and basket 2. Okay, here there is 1 2, here it is also 1 2, here 1 3 1 3, cool, here 1 1 1 1. Okay, but here 1 4 is present, here 1 5 is present. So you cannot swap them in any way to make 1 4 present in this or to make 1 5 present in this, because there is no 1 5. So how? Here is only 1 1 5. If there are two 5s, then you can swap this 5 with this, with some other fruit. But if there is only 1 5, then how it can be present here? So that's why you can't swap them in any way to make these baskets equal. So that's why you need to return -1. So now I hope you understood what the question is asking, like what you have to do. Okay, so let's try to understand with some other cases, like how we can approach to solve this question. Okay, so let's say we have these two baskets, 4222 and 1414. Okay, so first let's calculate the frequencies of each fruit with the cost. Let's say the fruit with cost 4. How many fruits we have? 1 in this basket, 2 in this basket. Okay, basically 3 fruits. How many fruits with cost 2 are present? 2 in this basket, 3 in this basket. Okay, 3. How many fruits with cost 1 are there? Okay, 2. Cool. Now what we will get from this information? Okay, so if there are odd number of fruits with some cost, right? So if the fruit with cost 4 are 3 in both the baskets, so how the baskets can be equal? Because if there are 3 fruits, then either in basket 1 1 4 can be present, and in basket 2 2 4s can be present, or in basket 1 2 4 can be present, and in basket 2 1 4 can be present, right? So how they can be equal? So if a fruit with some cost is present in odd frequency, then in no way you can make those baskets equal. So in that condition you will have to simply return -1. It means you can't make both of these baskets equal. Okay, so let's see how this frequency map will help in the question in which we need to return the minimum cost in which we can make the baskets equal. Okay, so let's say this is basket 1 and this is basket 2. let's calculate the frequencies in this case as well. So let's say the frequency of fruit with cost 4, 1 in this basket, 1 in this basket. Okay, 2 with cost 2, 3 in this basket, 1 in this basket. Okay, 4 with cost 3, 4 in this basket, any one of them? No. Okay, with 5, 2 in this basket, second, 6, 2 in second basket. Okay, we have left 1. Okay, so 1 in this basket, right? 2. Cool. Okay, so we have created our frequency map with the frequency of fruits according to their cost. Okay, now what we can do, we can create our to swap vector, let's say, which will basically tell us the fruits which we are supposed to swap. Okay, so let's see. So here are 4, let's say we will iterate in this map, and here are 2 fruits with cost 4. Okay, let's see, 1 in this basket and 1 in this basket. Okay, so we don't have to do anything with this one. Okay, now here are 4 fruits with cost 2. Okay, 3 are present in this one and 1 is present in this one. So it means we have to swap 1 fruit, right? So basically how we will get that, we will have to swap this 1 fruit only, because let's say we now here at this point we have created 1 single map, but in the code we will create 2 maps, one with the frequencies of this basket, one with the frequencies of this basket. So it will store the 3 fruits with cost 2 and 1 fruit with cost 2. So we will simply subtract these frequencies and we will get 2. It means here are 2 extra 2's which are present in one of them, and if there are 2 extra 2's, obviously we will have to swap only 1, because 1 will remain in this basket 1 and we will have to swap the another one. So we will simply divide this difference by 2 and we will get 1. So let's say we will have to swap 1 2, so we will store this in our to swap vector. Okay, now let's come to this one, 3. So here are 4 fruits with cost 3. Okay, so here in this the frequency of 3 is 4, and in this 3 is 0. So 4 minus 0, 4, and we will divide it by 2 because we are supposed to swap 2 3's, because 2 will remain in this basket only, right? So basically 2 3 will come in this to swap vector. Now again coming to 5, both of the 5 are present in this one, so we will have to swap 1 5. Now coming to 6, both of the 6 are present in this vector, so we will have to swap 1 6. Now coming to 1, both of the 1 are present in this vector, so we will have to swap 1 1. Okay, now let's sort this vector, because we want to figure out the minimum cost of swapping these fruits. Okay, so let's say if we will sort it, then it will become something like this, right? Okay, now the main thing, how we can calculate the cost. So let's say after swapping, so let's say we will swap this 1 with this 3. So what will be the cost? Minimum of both of them, right? So 1. And let's say we will swap this 2 with this 5. So what will be the cost? Minimum of 2 and 5. Okay, so now we will swap this 3 with this 6. Okay, and what will be the cost? It will be minimum of both of them 3, and total cost will be 6 of making both of these baskets equal. So this is the ideal scenario which you can think of. But there is one more approach, one more way in which we can figure out the minimum cost, because this is not the minimum one. Okay, let's see. So let's say we will swap this 1 with this 3 only, so cost will be 1. This 2 with this 5 only, so cost will be 2. But instead of swapping this 3 directly with this 6, what we can do, first we can swap the 3 with the minimum value 1 and then swap that 1 with 6. So in this way your minimum cost will be 1 for this swap and 1 for this swap. So basically overall cost will be 2 and it will be your minimum cost 5, right? So here is this one catch in this question, right? That instead of directly swapping both of these fruits, if the cost of swapping them directly is more than the cost of first swapping them with the minimum value and then minimum value with the desired output, so we will take that cost. So in this way we will be able to get our minimum cost. So basically what we are doing in this question, first we are storing the frequencies of each of the costs and then creating our to swap vector which will basically store the fruits which we need to swap to make both of these baskets equal, and then we sort this vector, and then we get our minimum cost. Okay, so let's try to code it to get a better idea. So let's say instead of this basket, let me just keep it v1 and v2. Cool. Now let's say n is equals to v1 dot size, and we have to create two maps. Let's say in comma int c1 cost 1 and cost 2. Now let's start iterating in our vectors. I is less than n, I plus plus, and c1 of v1 of I plus plus, and as both the size of both the baskets are equal, so we can do it in this loop itself. And we will also have to calculate our minimum value. Let's initialize it v1 of 0, because it will come into picture by calculating the minimum cost. So minimum value is equals to minimum of minimum value comma v1 of I comma v2 of I. Right, now what we need to do, we need to iterate in our map for auto it c1, and what we need to do, let's calculate the cost is it dot first, and occurrence of 1 is it dot second, and occurrence of 2 is, it means in the second vector, so we will get with the map c2 of it dot first. Right, and let's calculate their diff, absolute value of occurrence 1 minus occurrence 2, and if this value is odd, it means we can't make these baskets equal, so return -1. Otherwise divide diff by 2, because we will have to swap half of the values from them, and we will simply push them in our to swap vector. So let's also create a to swap vector, basically push in this to swap dot push back cost. Right, okay, now what we need to do, we can simply mark these cost as 0, so that in this, when we will iterate in the second map, we will not iterate them again. So let's do this thing for the second map as well. So it will be c2, it will become c1 of it dot first, it will become it dot second, and rest of the things will remain same. Now let's initialize our long result with 0. Let's start iterating in our to swap vector. I is less than to swap dot size by 2, I plus plus, and result plus is equals to minimum of 2ll into min value or to swap of I. Right, because to swap of I will give us the minimum value of swapping, and if it is greater than, then we will first swap it with the minimum value and then minimum value with the another value, and let's finally return our result. Okay, so let's try run this. I hope it works fine. Okay, oh okay, 1ll, let's see. Okay, let's try run this again. What happened? Oh, sorry, we forgot to sort it. Yeah, sort to swap dot begin comma to swap dot end. Yeah, now it should work fine. Yeah, it's working fine. Let's try submitting it. Yeah, so now let's talk about its time and space complexities as well. So as you can see, this is also big O of n iteration, this is also at max big O of n, this is also at max big O of n, and this can take at max n log n. So its overall time complexity is big O of n log n, and space complexity will be, as we have used these two maps for storing both of them, so you can say 2n, or we can write it as big O n. So yeah, this was all for this question. I hope you get it. This thing was little tricky in this question, but yeah. And if you still have any doubts, you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.